On this video, we're going to tackle task 17. Task 17 is calculating the cumulative incremental net monetary benefit for the probabilistic analysis. So on the right of my screen, I've opened the cumulative incremental net monetary benefit sheet, and you'll see that this has opened out quite substantially, actually. For this sheet, we are not just calculating the 2.5% and the 97.5% aisles, as we have done on previous sheets, but we're also going to calculate the percentiles at various other, primarily deciles, 10%, 20%, 30%, all the way up to 90%, but also 5% and 95%. And the reason we're doing them is we're going to plot them on one of the figures that we're going to have on the probabilistic result sheet. So the net benefit probability map. The net benefit probability map requires that we calculate each of these different deciles, primarily from 10% to 90%, of the distribution of the cumulative incremental net monetary benefit. So that's why we have them there. But otherwise, this is quite similar to what we've had on the previous sheets. So we're going to start with D49. We have to calculate the cumulative incremental net monetary benefit for each cycle and iteration. And if you remember back to part one, this was quite a difficult cell to enter, a very difficult formula, because we have to account for the half cycle correction in each one of these cells, not just in the total. So what I think a really good place to start is to select this, do a triple click and copy that, and then press escape and go down into here. And we're going to start with this formula. And I think I might need to just make this a little bit bigger. There we go. And let's just modify this formula. So the same logic about, if the half cycle correction is yes, then what do? We said if D22 equals 1, do we want that to be D22? We now have, we could keep it as D22, but I think it's a little bit neater to move that down to D48. Okay, so that's the row that has the cycle numbers in for the probabilistic analysis. You could keep it as D22, but what you do need to do is bear in mind that this formula is going to be copied down across all the iterations. So you don't want the D48 to change to D49, D50, because those cells don't have the cycle number in. So we're now going to lock the 48. Okay, so that's one important modification. Okay, now what was the logic before? If D22 is 1, then we're in cycle 1, so we're going to start with a baseline of 0. But if the cycle number is 2 or higher, we want to start with a baseline of whatever the cumulative incremental net monetary benefit was for the previous cycle. Okay, and so that's why you have C23. We need to change that to be C49. Okay, we're still going to add half of the incremental net monetary benefit for the cycle in question, but of course it's not going to be D23 anymore. So let's just go to the incremental sheet. I was hoping that formula would come with us. So it's not D23, it's going to be D38. So where we have 23, we need to replace it with 38. I'm just going to go back to this, and that 23, let's change that to 38. I was hoping, since I was still editing the formula, that it would let me switch to that sheet and continue editing it. Just while we're at it, we need to, multiply by this. The 23 needs to go to 38. And this final 23 needs to go to 38. And then what? We've got another one of these D22s, which I'm going to change to $48. And then C23 should be C49. So to save a bit of time, I've taken my formula from the deterministic analysis in D23, and I've changed what I think is necessary to make it work for the probabilistic analysis, having to take into account that this is going to be copied not only across, but also down, which is why we need to put these dollar symbols in here. I'm just taking a really careful look at this again. Is there anything that I've missed? I don't think so. I'm going to give that a whirl, see what happens. So it was previously marked as incorrect, but Oh, it likes it now. It's correct. Okay, so that's step 17.1 completed. In the next, we need to do the mean. So very much like what we've done before, we just need the average function here. We click on iteration 1, hold down Control and Shift, press down, close the bracket, press enter. And then in 17.3, we need to do the percentiles. So equals percentile. We're going to do the range from D49 down to D1048. Don't do the bracket yet though, because with percentile, we need to put a comma and then the actual percentile, which I'm going to click on this one. And the same logic we used before should work, even though there's a lot more of these percentiles. Basically, as this gets copied down, we want the 49 to remain fixed. We want the 1048 to remain fixed. We want the 34 to change to 35, 36, and so on. But when this gets copied across, we want the C to remain as C. So that looks good to me. And that's going to be copied across to the other cycles, and it's going to be copied down to all of these different percentiles. Yep, and it likes it. Okay, so step 17.3 complete. 17.4, review the cumulative incremental net monetary benefit up to cycle 60. So the spreadsheet is now opened and we can see all the way up to cycle 60. And what pattern do you notice? Well, right now I'm looking in this row. That's the most important row. And I can see the net benefits, just the cumulative incremental net monetary benefit is just getting lower and lower. As cycles pass, it's getting more and more negative. So treatment B is not cost effective and it just gets worse and worse as the time horizon gets longer. Optional, increase the threshold up to $100,000 per QALY. How does this affect the pattern? Okay, so we can go to settings, change this. Now what's going on? So if we move across, look at that. It eventually becomes positive. So if I start again, it's negative and it gets a bit more negative, negative 7,000, but then it's negative 6,000, negative 5,000. Eventually it gets back to about zero between cycles 51 and 52. It crosses zero until it's positive. So this tells us that with a threshold of $100,000 per QALY, treatment B does become cost effective, but only after 51 cycles. So you need a sufficiently long time horizon for treatment B to break even in terms of expected incremental net monetary benefit. And then for a longer cycle than that, treatment B does appear cost effective. It just takes some time for treatment B to pay for itself. Okay, and you need a sufficiently high threshold. If we put the threshold back to 50,000, well then treatment B is not cost effective at any time horizon. Okay, tick the checkbox when you're ready to start the next task. That's the end of task 17. So I will see you in task 18, where we put together the probabilistic result sheet.